So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. My name is Neeraj Kheria from Edureka. So yes, so today we'll be focusing on understanding Git. First of all, here we have the 10 most popular tools available in DevOps. So first of all, we'll be starting with Git, right? Git is one of the most popular open source version control tool. It simply means maintaining multiple versions of the same code, right? Suppose if we are working on any project and there are many changes that we are doing step by step, right? So for each and every change done on the file, a separate version will be saved so that if we want to roll back to the previous change, then we can do that easily using a part of version control tool, right? Git is a part of decentralized, or we can say distributed source code management tool, or so distributed version control system. Why distributed? Because first of all, here we have our workstation. Suppose if we have multiple workstations contributing in the same repository, right? So all those different workstations, they contribute, they are connected directly to the remote repository, right? So whatever change they do, they commit those changes directly into a central and remote server, right? Whereas in distributed, we don't commit the code directly. All the workstations, they do not commit the code directly to the remote server. First of all, we can commit the code to a local repository, and then we can commit it back to the center repository itself as a part of entire development process, as a part of distributed version control system out here, right? It is highly scalable. That means depending upon the requirement, we can add more number of servers, we can add more number of workstations. Again, depending upon the requirement, we can scale it up and down easily for getting adjusted as per the project requirement, right? And again, here we also have the concept of branching. And we will explore this once we start our focus module on Git and GitHub as a part of our subsequent sessions, right? Again, it is reliable as every contributor has its own local repository that we discuss as a part of the entire Git system, right? So since each and every developers will be contributing in their own local repository, that's why it will be much easier and much more reliable, so that even if in any case, if a remote repository is not available at any given point of time, then still the developers can continue working without worrying about deploying this or without worrying about unavailability of the entire central repository itself. All right. Now, and those companies are companies who are actually using Git. Now, we know the companies that we have: Microsoft, Amazon, LinkedIn, Accenture, Facebook, Yahoo. There's not a single company in the entire globe who is not using Git, because Git is the most popular version control system out there, because Git is easier to use. Git for Git, first of all, we have a working directory, or what we call as a workstation, right? And then first of all, if we want to start tracking changes, that exactly is called as the Git commit, right? And once we are done making changes, once we are done pushing the files to local, then we can push those files to remote repository, right, as a part of push. And again, if you want to pull something, that means we want to pull some changes. If suppose if multiple developers are they're contributing in the remote repository, then we can pull the code as well back to us, back to local repository, and then we can use those as a reference as well, right? Or we can edit those files as well as a part of Git, right? Now the entire setup here will be focusing in detail with the complete hands-on once we start our full focus session on Git as a part of a third class, as a part of a 10th class journey in different tools on DevOps, right? So this part will be focusing on once we start a full-fledged section on Git. Next, we have seen the tool for Jenkins. So Jenkins is the most popular continuous integration tool available. Why Jenkins is popular? Because of one main reason, because Jenkins has the plugin support for almost more than 100 plus tools out there. Suppose if a team is working on some specific tools, right, which may not be that much popular in the market, then all of those tools are available inside Jenkins, right? So suppose if we have a different repository in which we are submitting the code, then that particular repository can also be integrated using Jenkins, right? And that's why it has support for more than 2,000 plugins, not 100, not 250. It's almost more than 2,000 plugins are supported by Jenkins as a part of continuous integration, right? And again, since it is built in Java, that's why it is much easier to make it portable, right? To all the platforms that we can think of, right? So Jenkins is supported by multiple platforms. It is much easier to do to create a project and deploy those in Jenkins as we can think of, right? And these are the popular companies, those who are using Jenkins, starting with the Penthouse, Then we have OpenStack, Angular, Capgemini, Luxsoft, LinkedIn. These all are using Jenkins. Almost every industry out there, they're using Jenkins as a part of main continuous integration tool out there, right? And Jenkins, now, first of all, if we have to study the entire structure for Jenkins, then Jenkins start with the continuous repository itself, right? Suppose if here we are working on the entire structure for Git, now multiple developers, they can start contributing their files. Suppose we have 3 developers out here, right? And suppose each and every developer, they can start contributing their code to a central repository, as you can see here. Now, as soon as any particular developer, they share the code to the central repository, then Jenkins server will automatically fetch that code, automatically will pull that change being submitted. And then based on that pull, it will simply initiate a build out of it. Now, when we say build, it will simply create a build out of it means it will simply compile the code which has been pulled. It will review the code if in case of any kind of errors or any kind of errors being detected in that file here. Then multiple unit testing will be performed, followed by integration testing, and then it will be packaged using the var or jar packages, right, as a part of continuous integration here. And that's why we can, again, once the entire build has been created, then we can go ahead and deploy this as a part of user acceptance test, or we can deploy this on production, staging, or development environments exactly as per the requirement. We can do that, right? That's the entire setup for Jenkins that we can see, right? Then it comes down to Selenium. So Selenium is, again, it's an open source tool. That's the main advantage of Selenium. And basically Selenium is used to automate the entire testing, especially for the web applications. So if we want to test web applications, then Selenium is the most popular tool for doing that, right? And Selenium supports multiple platforms, including Java, Python, C, PHP, Ruby, Perl, JavaScript. So all the websites, all the applications built on these different platforms, they all are supported by Selenium here. And obviously it also supports multiple operating system as well as Windows, Mac, Linux, iOS, and Android. That's why it is highly compatible to almost all development environments. It supports all the languages in which the applications are developed, and that's why it is a favorite testing tool, a continuous testing tool by different developers out here as a part of continuous testing, right? In Selenium, what we can do, we can simply create multiple testing scripts, and then we can use those testing scripts to test out any of the component if they are currently visible or not, if they are currently functional or not. Then we can use the Selenium scripts to test that part out, right? And there are multiple companies that are using Selenium. Not a single company out there is available who is not using Selenium as a part of continuous testing tool out there, right? So companies like Google, Salesforce, IBM, JP Morgan, Cognizant, Fidelity, these all are using Selenium as a part of continuous testing, right? And Selenium is a complete of different softwares out here, right? And it can be used to perform both functional and regression testing, right? Now, when we talk about functional testing, we focus on different functions. That means, okay, how perfectly a particular function is behaving. Suppose, let's say we want to test out the functionality of any particular button out here, right? Then we can carry out the functional testing for the same itself. And again, if we focus on regression, again, suppose if we want to focus on the changes done, let's say our main focus is, again, we want to perform testing on any changes being done here, right? Again, then we can focus on regression testing as that we can achieve using Selenium here, right? And that's how we have discussed. It supports multiple platforms, operating systems, and browsers as well as a part of continuous testing, right? Now, after Selenium, we have Docker. So Docker, as we had discussed, Docker is the most popular containerization tool available, where it is basically focused on creating containers so that the differences between the developers and operations team can be bridged, right? Docker is the most popular tool for creating and deployment of containers, right? Now, when we talk about containers, we can say container is simply the package which contains the entire application plus all these dependencies on top of it, right? So let's go ahead and elaborate the same example. Just a moment. Now, we discussed, suppose there's a coder out here, right? Now, any coder, they want to share code with the operations team. Now, what the coder here, what they can do, they have a code built in Java. In coder system, they are working on Java 1.8, right? Whereas the operations team, they have 1.6, right? Now the coding team, again, they share the same Java code with the operations, but again, since they have a different version out here, the entire code will not function properly into their own system, right? That will create a compatibility issue. And just to make sure that these kind of things does not happen, what the coders they can do, instead of sharing just the code, they can share the entire container, which will not only package the application, that means the entire coding files, but it will also package all the libraries and bins for making sure that the entire execution is done properly as it should, right? So all the dependencies will be also packaged inside the entire container itself, right? So that once we deploy this, again, the same operations team can simply, instead of worrying about the versions, what they can do, they can simply focus on running the container. So they have the container which has been already created and built using the tool here, and they can simply focus on deployment of this container, right? So they don't have to worry about the operations team here. They don't have to worry about the actual deployment, and they can simply run the container inside the Docker ecosystem out here. That's the main concept of containers, right? And that's why Docker is the most popular containerization tool available for solving this issue out here. All right. Now, after Docker, here we have a tool named as Puppet. So Puppet is one of the most popular configuration management tools available out there. And again, it is mostly used for deployment, configuration, and management of servers, right? For example, suppose here we have one particular server that needs to be configured. Then we need to have a specific version or different modules that needs to be executed or that needs to be present. We need to have a specific set of the computation that needs to be configured for that server here, right? So all of these different configurations we can do for the servers manually. We can open the server configuration and we can perform all the configuration pointers manually. That means one by one ourselves, or we suppose now this is good. We have one or two, or suppose let's say we have 1 to 10 servers, then we can do the manual configuration on our own. We can do that. That is feasible. But if we have thousands of servers to deploy, and that too in shortest time possible, right? If we have thousands of servers to deploy in the shortest time possible, then doing all of these configuration manually will not be feasible, right? So what we can do in those scenarios, we can simply use a configuration management tool. Using configuration management tool, we can simply work on designing a complete template. Just say we have a template structure, right? So here we can design the entire template, which will contain the information what needs to be configured, what should be the configuration of each and every server, and then we can simply use the configuration management tool to replicate the configuration for each and every number of servers that we want to apply here as a part of configuration management tool. And that's why here we have Chef, we have Puppet. So these are the most popular configuration management tool. Which tool we have to use here, that depends upon our requirement, which we will be exploring step by step as we continue ahead into our focus modules for these tools in our subsequent sessions. All right. And that's how we use configuration management tool out here. So now let's erase this up. And then here we'll be focusing on something as Chef. So here, first of all, let's discuss on Puppet itself. A quick overview for Puppet. So Puppet here basically works on the slave and master layout. So Puppet has a configuration of slave and master layout, right? Here we can work on the master. Now, first of all, master can simply, now we have a configuration of Puppet slave and Puppet master here, right? So first of all, the slave will send the facts about the node. Now, when we talk about node here, right? Here we have something as slave and master, where a single master can have multiple nodes connected to it. We can say master will be the central system itself, where suppose if you want to configure multiple things for all different system out here, right, then they can be considered as slaves, right? And now here we have, first of all, the slave will send the complete information about itself, that means about its IP address, about its entire information, right? And then once the information has been received by Puppet master, and then again Puppet will use a fast that has been shared by slave, right, to specify how it should be configured. And once the entire configuration has been done, then the report of that configuration will be sent back to the master as a part of slave and master layout followed by Puppet. And then we have Chef. So Chef is again most popular tool available for the configuration management tool, right? Now here is suppose multiple platforms including Archer, CentOS, FreeBSD. It is also a part of open source tool where the companies using Chef are Firefox, Expedia, Facebook, Walt Disney, HP, Rocket Space, right? and then these all tools are available as a part of Chef. And Chef is again a centralized store for all the configuration of the server here, right? Again, Chef itself runs on the node as compared to Puppet, right? So Puppet works on the slave master architecture, whereas Chef does not work on that kind of architecture, right? So again, all the systems managed by Chef itself, those are called as nodes, right? And Chef uses the API, Chef uses, and Chef and Knife, right? They all uses the API clients to talk to the Chef server, right? The last tool available for configuration management, here we have Ansible. So Ansible is again an open source configuration management tool where it mainly focuses on push, right? So as we discussed, if we talk about Puppet, so Puppet first of all works on the pull configuration here, whereas in Chef we mostly focus on the push configurations, right? Again, it has a master slave architecture, same as Puppet. Here we don't have to worry about creating multiple agents, right? And here we use simply created syntaxes using the YAML language. And the companies who are using Ansible, these include Capital One, YSAT, and then we have NASA as well as a part of the most popular companies using the concept of Ansible. All right. So in Ansible here, we focus on the entire architecture for connecting their databases for users. Then here we define the entire Ansible playbook where we can use this playbook to configure. Now, just like we have templates in Puppet, right? Same way here we have playbook. So playbook is used to provide all the configuration for the entire system, right? As a part of Ansible configuration management tool. And Splunk is, as we know, is one of the most popular tools for the continuous monitoring, where Splunk is mostly used for storing, searching, and analyzing information that's all generated by machines, right? And basically, it is used for creating the knowledge objects, right? Again, it simply monitors all the business matrices that is available out there as a part of Splunk, right? And again, the companies who are using Splunk include Cisco, Facebook, IBM, Bosch, Motorola, Domino's. These all are using the concept of Splunk, right? Now, first of all, we need to have data input being shared to Splunk. Then the parsing happens, then the indexing happens, and then at the end, the searching happens as a part of Splunk tool out here, right? In simple structure, here we have a forwarder, then we have indexer, and then we have the search head as a part of the entire tool shared by Splunk, right? First of all, Splunk will collect the data from the remote machines, and then that data is again forwarded for the real-time analysis, right? Now, the main job of indexer is they can simply process the entire incoming messages in real time, and they can store and index the data that has been given to them on the disk. That's the main job of indexer, right? And as why parsing and indexing, these are part of the indexer itself. And then we have search head, where we can use this to interact with the Splunk using a search head. Actually, this is a front end for the entire Splunk, which can be used to perform searching, analyzing, and all the visualization can be done easily using the Splunk platform. And then we have ELK. So ELK is simply Elastic, Logstash, and Kibana, right? Elastic, Logstash, and Kibana as a part of ELK. So ELK is simply a powerful connection of three open source tools. Like we have Elasticsearch, Logstash, and then we have Kibana, right? Logstash is, as we can say, a data collection pipeline tool, whereas Elasticsearch works on low SQL database because here we don't get the idea for any schemas. And then Kibana is a data visualization tool. Suppose once we have captured the data, then how we can visualize this. Same way, like we have a real-time analytics tool available in AWS by the name of Kinesis. Same way, here we have tools like here we have companies like we have those who are using ELK include Netflix, we have OpenStack, we have Accenture, and then we have LinkedIn as a companies. Those who are using the ELK platform out here. All right. And at last, we'll be focusing on Nagios. So Nagios is basically used for monitoring purposes, where it can be used to monitor and troubleshoot any server performance issues, right? Suppose if one server is being overloaded, if one server is continuously failing or it has been in use at its 100% capacity, right? So these all things can be reported easily by using the concept of Nagios, by using the tool as Nagios here, right? And basically, it simply allows us to plan the infrastructure upgrades before any system goes outdated. Suppose a version of any system needs to be updated, then we can do that easily using Nagios, right? It can be used for automatically fixing the problems as soon as they are detected here. Because here we need to perform the analysis on each and every phase out here. That means what is happening with the continuous development, what is happening with the building tools, what is happening with the Jenkins, right? So these all things has to be well thought of and well monitored as a part of Nagios tools out here, right? So here it can be used automatically to fix all the problems when they are detected. As soon as they are detected, this can be used to perform the analysis, right? And this can be reported in real-time scenario when we have the notification systems put in place here. And the companies who are using Nagios, again, almost every company is using Nagios, but again, here we can refer to this tools as Comcast, Yahoo, Sony, MTV, Toshiba, Siemens. These all are using Nagios as one of the most popular tool available for the continuous monitoring out here. So Nagios again has a complete web dashboard, and that's why Nagios is most popular, because again, in other tools, there we get a simple log file as a dashboard here as a part of application, right? Whereas in Nagios, we simply get the entire interface as a web interface that we can use to get started, right? So again, as you know, we can connect this to multiple notification system out here where we can send the notifications as a part of complete tools here, right? Where we can use this to connect this to the entire notification system. And then if we have focus team on keeping a check for the entire system, focus team for keeping a check on the health monitoring system, then we can notify them using this entire system here. So now I think we are done with the entire overview for all the tools out here, guys. So I guess it's almost time now. So let's say we wrap it up for today. So kindly just show your love by hitting the like button, and again sharing the entire video as much as you all can, right? Take care. Bye bye.